Hello there, another look today at Quotient Rule, exercise 10C.2. I'm going to start off with a little song. That can't be said it happens too often, does it? So let's see if we can run this. And here it is, let's have a look.
Quotient rule, the quotient rule. I'll use the quotient rule, the quotient rule. Low D high, minus high D low. Square the bottom and away we go. Low D high, minus high D low. Square the bottom and away we go. I'll use the quotient rule. Thank you.
So maths can be fun, that's true. So I suppose the mere fact I made you watch that tells you that it's quite an important rule, and it also it's a rule that two bored students in the middle of America, it would seem, thought important enough to write a song about. I'm not sure it's a great song, but I mean, if you remember the rule, we basically have said that if you are looking to differentiate a function which is u divided by v, we've said that dy by dx is v u dash minus u v dash divided by v squared. And they said, what did they say? Low d high, that's what they said. They said low d high minus high d low. Square the bottom and away we go. So the low bit is obviously meant to be the v, then differentiate the high one, which is u, minus the high, which is u minus times by the differentiated low one, which is the v dash. Look, I mean, clearly it's just a different way of learning the same rule, but if at least one of you remembers that rule on the exam day because of that silly video, then fair enough. Look, we're going to practice this now. It says use the quotient rule to prove that differentiating tan gives sec squared. So the obvious thing is tan x doesn't look like a quotient, but of course we know that a sine divided by cos is tan. So I'm writing that there, and that's my tan. So this seems to be implied then, where you write u equals sine x, and v equals cos x, and u dash. Now again, just remember this rule, sine cos minus cos. If I differentiate sine, I get cos. If I differentiate cos, I get minus sine. So let's put that into my rule. Dy by dx equals, now it has to equal, using this rule, v u dash cos x times u dash, which is cos x, minus it's u sine x times by v dash, which is minus sine x. Well, that minus, I suppose, minus and minus makes that a plus, all over v squared, which is cos squared. Now, just look at the top bit there, you end up with cos squared x plus sine squared x over cos squared. And the lovely thing about that is sine squared plus cos squared is 1. That's a formula you should remember. So it's 1 over cos squared, and if you know anything about your reciprocal functions, you know that can be written as sec squared. So therefore we've proven it. So that's the proof, and that kind of proof does come up. You meant to know those kind of basic proofs. Use a quotient rule to find dy by dx when log x is y equals log x over 2x minus 3. Okay, so we've got the function y equals log x over 2x minus 3. So let's go through the same rigmarole. U equals the log x, and v is 2x minus 3. U dash therefore is 1 over x, and v dash is 2. So I should be able to write dy by dx is v. Always start. We just remember this is always starting with this v. So it's 2x minus 3 times by 1 over x minus these two, uv dash log x times by 2. I might slide the 2 in there. All divided by the bottom squared. 2x minus 3 squared. It's not very nice. I don't know if that's the answer. Let's see. Yeah, more or less it is. Now they've tidied up the top, so I'll go back and tidy up the top. But broadly speaking, that is the answer. So you put the whole of this thing here over x, so you get 2x minus 3 minus 2 log x. Now the only problem is if I put this over x, I'd better put. I'm going to make this minus 2x log x. So when I divide it all by x, it hasn't changed, and that's then divided by the 2x minus 3 squared, which means I end up with 2x minus 3 minus 2x log x. And when you have a fraction divided by another fraction, well, what is effectively a fraction, that x goes on the bottom with it, so it's x 2x minus 3 squared. I suspect that was the answer we saw on the next slide. Yes, it is. So that's exactly right. Now what does it ask me to do? Hence find the equation of the tangent to the curve, this curve, at 2 log 2. Right, and so we know that our x value is that and our y value is that. So presumably if I sub 2 into this, so I'm just going to write it up here. When x equals 2, I'm going to find dy by dx. And it's 2x, which is 4, minus 3, minus 2x again, which is 4 log 2. Okay? All over x, which is 2. Now 2x is 4, minus 3 is 1, times by 1 squared. 4 minus 3 is 1, minus 4 log 2 over 2. That's as good as anything. So that's effectively my m. So if I just write that here, m equals, let's see what it was again, 1 minus 4 log 2 over 2. And I have a y coordinate of log 2 as well, so my x1 equals 2, my y1 is log 2. Just check that again. Yeah, I've got that right. So chucking it into my equation, y minus y1 equals m x minus x1. I'll just check it does say tangent, doesn't it? Yes, sometimes it says normal, you've got a reciprocal, a negative reciprocal, the gradient. Not here though, so it's y minus log 2 equals m, 1 minus 4 log 2 over 2 x minus 2. Now the first thing to do obviously is whack that 1 up, that 2 up there, so I get 2y minus 2 log 2 equals, and I've got to multiply this out, I've got 1 minus 4 log 2 times by x minus 2, which is, let's just do this, that's x minus 2 minus 4 log 2 of x plus 8 log 2. So I just got to tidy this up a bit. The 2 log 2 comes over and becomes 10 log 2. So I get 2y equals, and I've got an x, and it might be better for me to join those together actually again. Let's join them back together. Minus 4 log 2 times by the x. That's that dealt with and that dealt with. They come over, gives me 10 log 2. And I think of anything I've got left now is that take away 2. It's not very nice, is it? Let's see if the actual answer is what they've got. Well, it basically is, you know. The only thing I've got to do is just move the y over, the 2 over, sorry. And I'll get 1 minus 4 log 2 over 2 lots of x plus 5 log 2 minus 1. When I divide those 2 by 2, I'll get that. And that's right, that's the right answer. So it's not pretty, but it is the right answer. So we're going to practice this in lesson. We've done a few questions in this video, but basically we just build on what we saw last time and seeing hopefully that we can now do them.